So when we do the shape of a lens, this shape is called convex. And how do we remember like the convex shape again?
The edges bend outwards.
Right, the edges bend outwards. Now when we talk about the behavior, is this converging or diverging? Converging. So if I took my lasers and I send lasers through, I traditionally draw them so that they don't change direction until they pass the vertical axis of my lens. That's going to make it a lot easier when I do measurement. So this has a focal point here, and we'll call this behavior converging. Converging means the light rays go together. So convex, converging, excellent. What was one of the focal lengths you measured for this one? Sure. So let's say I measure the focal length of 7.5 centimeters. I'm going to call that positive. And I'm going to call it positive because those light rays literally intersect. Okay. How would I take that 7.5 and turn it into a radius? Double it. So what would I get here? 15. Awesome. A thing to note, radius of a circle can't be negative. So no matter what F does, R will always be a positive number. Radius of curvature is twice as big as the focal length. So let's do the other one then. If I had my other shaped lens, what's the other shaped lens called? Concave. And how do we remember that?
The edges bend
Bends inward, like a cave. So concave lens, that's the shape. What's the behavior? It diverges. And a thing to be careful about with diverging is they don't just like randomly go apart. They go apart as if they all came from the same location back behind the lens. So we would call this a negative focal length because the light rays literally don't meet up there. The light rays are these three rays that go off over here. Your brain, however, being very smart and good at like coming up with patterns is like, okay, I see three diverging rays of light, but they're all giving me the same picture. Those must all be from the same place. So I want you to imagine when you see diverging, that the brain's over here with our person looking mildly confused. Right? They're looking at this light and they're like, where did it come from? And the brain thinks to itself, oh, that light traveled in a straight line. It must have come from way back here. Diverging rays create what's called virtual images, and they have negative focal lengths. So can you give me, what did your group get for your focal length for your concave lens? Quinn? 6. Positive or negative?
Positive.
Other one?
Negative.
Right. So even though when you measure it, you're gonna like grab a ruler and it will literally measure out to be some positive number, right? Throw a negative sign on because it's diverging. Okay, but radius is still double that. So what's the radius then? 12. Except radius is always positive.
That's not double.
I know, it's kind of a pain. So how it works, focal length could be positive or negative, but radius is always positive. So to turn focal length into radius, you multiply by 2. And radius should always be positive, so just absolute value that when you get there.